Hello, dear aspirants. This is Dr. Saurabh Sir's class. We are now solving our National Boards of Higher Mathematics previous year questions. This is from our PhD entrance examination from the year 2019. So the question says us that we have to find which of the following statements are true. So what the first statement says that if our A yeah, if our A belongs to MNR, I have told that our MNR is what? That is group the group of the matrix, the set of the matrices who has the order n and all the real entries, such that our inner product of ax comma x is equals to 0 for all x belongs to Rn. Then what will happen? Then our A will be 0. Okay. So firstly we want to try a counter example for this. Let our A be, let me write it in another color, so blue will be the perfect now. So let A be 1 minus 1 1 0. No, that will be, yeah. Then what will happen? Now then for any matrix let x be of this kind. X1 and x2 belongs to R square. Then what will happen? Then we have our inner product ax comma x, which is equals to my minus x1. Sorry, this will be x2 x1 dot our x1 x2. That will be what? Minus x1 x2 plus x1 x2 equals to 0. But our A is this. A is not 0. But the other conditions are satisfied. So the statement A is false. Yeah. So our statement A is false. So now we have to consider for our B. So B says what? That if A belongs to MNC, that means AVM square matrix of order n with the complex entries, which is such that AXX inner product is equals to 0 for all x belongs to Cn C to the power n, then our A will be 0. Also we have to think about that. Now, we know that every complex matrix A can be written as what? B plus IC, and B and C are my self-adjoint matrices. Okay, then the condition gives us what? Condition tells us this thing. For all x. So we will have what? Our B plus IC, yeah, x will be now equals to 0. Then our bx comma x will be plus I, this thing is equals to 0. Then Now for every x, now for all x, our these things, that means our bxx inner product and our cxx inner products belongs to R. Since B, C are self-adjoint, now thus, I want to change my color to the blue one. Thus, what will happen? Thus, our bx comma x and cx comma x both will be 0. We can write this equal sign also for all x greater than 0. Is for all x. Okay, now we know by the spectral theorem in the finite dimension that is our B will be diagonalizable since is normal. This is from our spectral theorem we got this. I am writing it for your knowledge, that is from spectral theorem we got that our B is diagonalizable as B is normal. Okay, now our sorry, yeah. So now our if u be an eigenvalue, sorry, u be an eigenvector which is associated to the eigenvalue lambda, then our bu comma u will be 0 equals to lambda u comma u. That means we for the eigenvector, yeah, yeah, for the eigenvector u, we can say that our bu is equals to lambda u. We are using it here, this thing. So our as norm of u cannot be 0, as our eigenvector is a non-trivial solution for the system, this system of equation. So lambda will be 0 in that case. Thus any eigenvalue is 0. Any eigenvalue is 0. Now since our B is diagonalizable, that means B is equals to 0. As all eigenvalues are 0, so the B can be diagonalizable, then all the diagonal entries also be 0, then B is my 0. Okay. That is the same occurs for C also. Then my C will also be 0 and my A will be what? 0 plus I 0, that will also be 0. Okay, so our B is true. Now we have to check about our option C. C tells us what? If A belongs to M and C is such that A x ax dot x or x inner product x a comma x inner product greater than equals to 0 for all x belongs to Cn, then our A is equals to A star. That means conjugate transpose. So what will happen now? This thing happens when our A is a Hermitian matrix. Okay. So now our C gives us what? It tells us that let our ax comma x greater than equals to 0 for all x belongs to Cn. Now what is happening? Now our inner product ax comma x is equals to This is just the transpose. This is just the conjugate transpose. So we can do another thing. Let me take the bar. Okay. So we will get this. Everything is happening for our x. For all x belongs to Cn. So now my 0, yeah, 0 is equal to this. So then we will prove that our C is identically 0. Then which means our A is equals to A conjugate transpose. Then first apply C to our x plus y. Then we are applying the C to our x plus y. Then we are finding that what will we get. So that is my, let me change my color. Yeah, to the blue one. No, I want to use the yellow one. Okay. So my 0 is equals to C of x plus y, comma, that is my x plus y. And this thing gives us, yeah, we can write it this. Okay. Gives us what? Our cx comma y and plus the cy comma x is equals to 0. So now another thing, our 0 equals to c, that is my ix plus y, comma হচ্ছে ix plus y, that is equals to what? Then the minus case will occur. So our cx comma y minus cy comma x will be equals to 0. Then my cyx will be 0 for all x y belongs to x. So our c is identically 0, as we can easily see that this thing is also 0. So our c is identically 0. Then what will happen? So our option B and C are correct. I want to close it. So our option C is also true. So the required answer of this question is that our A is false and B is true and C is also true. So this is my required answer of the question. Okay, thank you. Goodbye.